All right, just a little side note. If you are not an amazing athlete, you can probably blame your parents for not making you practice when you were really young. Scientists are finding, this came out of the New York Times, that, well, I'll just read it to you. Favorable genetics and a well-conditioned body are essential, but some scientists believe that physiological changes in the brain that take place during repetitive practice at a young age may make the difference between a world-class athlete and the rest of us. So in other words, a lot of those amazing tennis players or basketball players were playing at a really young age, and that actually makes a difference in your brain. And so if you weren't playing at a really young age, it would definitely be a disadvantage. I'll give you an example. When you're, I know a guy who, to develop hand-eye coordination with his little kid, plays a game. He like tapes like a little wiffle racket to his kid's hand. Why tape it? Because the kid doesn't have enough coordination to be able to, and strength to hold onto the racket yet. He's so little. And he has him bat at like little paper balls. Tosses a paper ball at him, and he's supposed to just hit it. And the kid loves the game and is developing hand-eye coordination for the kid at a young age. So that kind of stuff actually scientifically is proven now to make a difference. So obviously if you were able to get a 2-year-old to play tennis with you, great, but that's not going to happen. But at least you can develop hand-eye coordination with them. Did you see Tiger Woods at a young age? Anybody see like pictures of him when he was on Johnny Carson and stuff? It's this little kid swinging the golf club really well. And so that's another proof of somebody who developed at a young age. So, what? Okay. All right, so anyway, and one more thought on that. It builds myelin in the brain. Myelin is this stuff that goes over the top of your brain, and it's like it's the stuff that makes your brain gray. So when you look at a cross section of a brain, you've probably seen them on pictures and stuff. They're a lot of times gray. The top of your brain is gray from the myelin, and the myelin, apparently, this practice at a young age can make myelin develop. And the more myelin you have, the more developed your brain is, the better it works. And so people that have a lot of gray, a lot of myelin. I'm guessing that Einstein probably had a lot of myelin in his brain, but I don't know. All right, moving on. Inequalities. This is just an equation, and I've graphed it. It's not an inequality at all. It's an equality. And inequality is where I change that equal sign to like a greater than or something like that. So let's do that. Now it says greater than. So now here's the graph of it. Where is that graph greater than 0? Remember, this is like y. So it's like I'm saying I want y to be bigger than or equal to 0. Do you see that it's bigger than or equal to 0 from here on? Stays above the line. So if being bigger than 0 is kind of the important thing, all of your equations are going to be set equal to 0. Why? Because quadratics and cubics and things are a lot easier to solve when they're set equal to 0. When they're set equal to 0 or greater than 0 or less than 0, then this becomes the important spot right here. What are these things that touch it called? The zeros, the x-intercepts, the solutions, the roots. They're important again. They keep on being important. All right, so if I knew what this guy's zeros were, then I'd be able to do it even without the graph. And a lot of times you're going to have to do these without the graph. And if you want to graph it, it's really easy. You hit graph, and you see which part of the equation is above the line. And so how would I answer this? Remember, the answers for these are x numbers. They're like numbers for x. What are some numbers for x that would work? Well, anything that's bigger than what? -1. So from -1 to infinity. Does it work at -1? At -1, it'll be 0. Is that okay? It says or equal to 0. Yes, it works because it's 0, and 0 is equal to 0. So there might be my final answer right there. The graph is not an answer. The graph is a way to get your answer. All right. So these don't have graphs with them, but they can still be solved fairly easily. All right, so I want you to start with this one. X squared is greater than or equal to 0. Just think for a second. If I have something and I square it, is it ever going to be negative? No. So is there any, how about this, is there any number that would work Are there lots of numbers that would work? Are there any numbers that won't work? There's nothing that won't work, so everything will work. So how do I write that? Negative infinity to positive infinity. That's it. All right, you're going to want to write down a few of these. So grab your notes and start taking notes. Copy a few of these down because these are not intuitive. They're not. Once you've done a few of them, it's no big deal, but that's kind of the point. We've got to do a few of them together here. X squared is greater than 0. Will that ever work? Yeah, it works a lot of times, doesn't it? Is there any time it won't work? So what you should say is everything works except what? And how do I write that with intervals? Negative infinity up till when? 0, and then it stops working, and then union with 0 to infinity. You get how that's the answer to that inequality? All right. How about this one? How can I make the opposite of x squared be positive? Well, just start thinking of it this way. Can you think of any number that could make it work? Or do most numbers not work? Pretty much nothing works, except is there anything that does work? 0 is the only thing that works. So actually, I don't think we've ever run across that. How do you write an answer? Normally we write from 0 to like 3 or something, but in this case it's 0 to 0. How do you write that? You could write from 0 to 0. And would you put brackets or parentheses? Brackets, because otherwise you're saying it doesn't work at 0. That's an okay answer, or what do you think is another way to write it that's simpler? Just a 0. And x equals 0 is an okay way to say it, but a 0 in a bracket is what we'd really be looking for. So if you have a single number answer, you can just put it in brackets and be done. All right, next one. Look at this. Is it ever going to be positive? Well, that depends on it's sort of the sum of its parts, right? This is always going to be positive, right? Right. Is this always going to be negative? Ignore 0 for just a second. Just ignore 0. Other than 0, won't that always be negative? Yes, it will. Because remember, this negative is not in a parenthesis getting squared. That negative is outside it, so that negative is going to make it the opposite of whatever it was. So this will always be neg. This will always be pos. When you multiply pos times a neg, isn't it always negative? So basically, I figured out that this thing's always negative, but I want my function to be bigger than or equal to 0. It won't ever be that unless, what's the one time it would work? 0. Because if I actually put in zeros, this would become 0, this would become 0, and 0 times 0 is 0, and that's equal to 0. So 0 is the only time it works, so the answer is the same. Only at 0. See how you think these things through? The more advanced problems are like this one. And let's that lined up. There, that one. And I'm going to move this out of the way here. We'll deal with that later. Okay. On this problem, I need to teach you a way of keeping track of, you remember how I was saying this is always positive and this is always negative and that kind of stuff? There is something called a sign chart. You need to learn how to make one. When they're all said and done, they look kind of like that. They are a number line, and they got dots on the number line, and there's positives and negative zones. This means that between here and here, it's positive. This means the function's negative between here and here. This means the function's negative between here and here, and it's positive from negative infinity up to here. You know what I mean? Like in there. All right, so that is called a sign chart. You're going to learn how to make one of those right now. So in your notes, draw a number line like this. What do you think the important spots on the number line are? The x-intercepts, also known as the roots, also known as the zeros, which in this case are what? What makes that part 0? Negative 3. Negative 3 is one of your important spots on the line. How about this spot? 0. Okay, now this is important. At -3 and at 0, when I stick in -3, what do I get for an answer? Is 0 greater than or equal to 0? So it works. So put in a filled in dot right there. Now at the 0, when I stick in a 0, does it work or not? It's 3 times 0, which is 0. Is 0 greater than or equal to 0? Yes, it works. Are those spots always going to work? No, they're not. You have to be careful with those spots. Sometimes they work, sometimes they don't. Sometimes they make an asymptote, like later on and that's a big deal. All right, so next thing. I need to figure out where this function is going to be positive and where it's going to be negative. So I now need to test this region right here. What's a number between -3 and 0? How about -1? Let's test -1. So that's what you do. You write a little -1 down there. The answers are always going to be above the line. I used to put them below the line, but now we're trying to do it all the same in all the pre-calc classes. So the answers for this will go above the line, and they're either pluses or minuses. We're trying to figure out where is this function positive, where is this function negative. All right, so if I stick in -1, I'm going to stick it in right here and here, and I'm going to do my work down here below. The workspace is like down in here. So I'm going to like figure out what's -1 plus 3. It's 2 times what's -1 squared. That's 1. Does that, all it matters now is, does that come out positive or negative? Positive. So we put a big plus right there. The function is positive between -3 and 0. That does not mean that that answer is like what we wanted. We look at this sign later. We just start figuring out that the function will be positive in this zone from here to here. Okay? All right, now let's test another spot. How about, what's something bigger than 0? 1's a nice number. Let's test 1. So if I put in a 1, 1, 1. What's 1 plus 3? Workspace is down here. 4. What's 1 squared? So 4 times 1? Is positive or negative is all I care. Put a big plus. All right? In the back corner. Tell me how to test somewhere over here. Okay. If I put in -4, you tell me in my little workspace here, what should I write? Yep. Is it positive or negative 16? You're right. So is the final answer positive or negative? Put a minus up there. Get that? Okay. Now, have I actually answered the question yet? Nope. I've just made a chart that tells me now where it works. Where is my function greater than or equal to 0? It works in this zone right here and in this zone right here. And be careful with the endpoints. Write what you think the answer is as an interval. Something, comma, something. With parentheses or brackets. And I'll call on somebody to tell me what they think it is. All right, here we go. How about let's check out in the front row here. -3 bracket to infinity. All right, I'm going to check you now. So you're saying it works from here over that way, and that always works in that whole zone. Anybody agree with him? You're right. Good job. Now, could I have said from -3 to 0 and then 0 to infinity? Sure, but that's like wasting, it works at 0. So there's no reason I have to do that. All right. Next problem. Where does that work? Again, I'm looking for answers that look like this. That kind of thing. Where does that work? It doesn't work. Explain yourself. You can't do that. So what's the right answer? Oh, I agree with that. I'd also accept no solution. I'd also accept that. Okay? All right. Here's another one. Remember, you can graph these again. And if I want the parts that are bigger than 0, it's going to be really easy. It works in here, and from there on. Write me the answer in interval notation. In case you're having trouble reading this is at -1 here, and at 3 here, and at 5 there. It's really easy if you graph them. But there's kinds that are really a pain to graph, and really a pain to read the graph. And so those kinds are better with the sign chart. So we want to show you both ways. But if I actually graph this thing, where is it bigger than 0? Where I drew in red. So it's between -1 and 3. And does it work at -1? That's important. At -1, right at that spot right there, it does not work because it would be 0. And is 0 bigger than 0? No, it's not. So it's a parentheses. And then I'd say union with, the rest of it is from 5 to infinity. Raise your hand if you had that one right. All right, how many of you thought it was brackets? All right, did you get that it can't be brackets because these spots are 0 and it has to be bigger than 0? You get that now? Okay. All right. Here's one, and it's completely different because this is a rational function. Do you remember finding vertical asymptotes? You remember finding x-intercepts? Well, remember that the x-intercepts, if I was to graph this thing, if I told you that the graph kind of looked like this, remember these kind of graphs? And it's got, this one's got 2 asymptotes. Do you remember how the asymptotes are at -1 and at 7? And so there's an asymptote at -1, it like looks like this, and there's an asymptote at 7, and it looks like that. Do you think this spot and this spot are important on my sign chart? Yes, they are, because they're spots where the function doesn't work. So those are important spots, just like the x-intercepts are. The x-intercepts are where, fill in the blank, y = 0. That should be ingrained in your head. X-intercepts are where y = 0. So if this is 0, where are my x-intercepts? Where the top is 0, and so it's at -5. So that also must be an important spot. So there's 3 important spots for my number line, and now I can actually do the same thing I was doing before. Here's -1, here's 7, and here's -5. I got 3 important spots on my sign chart. Draw that sign chart, please. Is 0 an important spot on this graph? Nope, it's not one of the roots. It's not one of the asymptotes. So now I got to figure out, like, you know, is it positive, positive, negative like it was that other time, or is it, you know, positive, negative, positive? I mean, you never know. A lot of times they change. Like two that are next to each other are a lot of times different, but not all the time. So you really have to test each little interval. So name the easiest number to test that's somewhere in this zone. 0. So if I stick in 0 into my equation, I can show my work down here. 0 plus 5 is 5. 0 plus 1 and 0 minus 7 are 1 times -7. Is my final answer positive or negative? So I put a negative up there. Okay, I just tested 0 and it came out negative. Now let's test something bigger than 7, like what? How does 8 sound? I stick in an 8. And now I have 8 plus 5 is, doing my work down here, 13 over 8 plus 1 is 9, 8 minus 7 is 1, 9 times 1 is 9. Those are all positive, so it's positive. Okay, what I'm doing here? So it's pretty much the exact same thing as last time. It's just that you've got more things to watch out for. It's not just the x-intercepts, it's the asymptotes. So there's going to be more things on the line like this than there were before. Otherwise, it goes the exact same way. Now we test something that's out here and like between these two numbers, like -4, and I see if -4 works or not. And I test it in here, and I think you get the idea. All right. Here's one where I'm giving you the graph. This is called the sign chart. I'm going to put an asymptote line through here just so you understand why that's an empty spot on the line. And I want you to tell me what the answer is. The answer is like negative infinity to 7. Something like that. Come on, stay with me. We're almost done here. So you're looking for a spot where the function is bigger than 0. So what do I want, pluses or minuses? I want the pluses. So where is my function going to work? From negative infinity to negative 4. Does it actually work at negative 4? How can you tell? Closed in dot. Let's bracket here. All right, union with, when's the next spot it works? 3 to 7. Does it work at 3? Does it work at 7? Yes. Does it work after 7? Nope. So there's your answer. Raise your hand if you had it right. Good. Okay. This is like the hardcore stuff that we're going to get into tomorrow. The only thing that's more hardcore about it, really, is that it's harder to find the asymptotes. That asymptote is at 4/5. It's not that hard. This one's imaginary, which starts to blow your mind a little bit, but we'll deal with that kind of stuff tomorrow, so don't worry about that. Basically, you find all your x-intercepts, which are on top. Remember that. The x-intercepts are on top, the verticals are on the bottom, and you put all of those things, the x-intercepts and the asymptotes, on your line, and you test in between them all, and that's all you have to do on these. These are kind of like, you know, a lot of grunt work to figure them out, but it's not, they're not incredibly complicated math. In fact, one kid last hour said, like, yeah, this feels a little bit like 7th grade. It seems kind of easy, but, and it is. But really, look what you're doing. You're figuring out where that function works. That's a big honking function. So it's, you know, an impressive problem if you really come down to it. You ask the average person on the street how to do this, 9 out of 10 of them have no idea what you're talking about. But you can do it. Okay. So your assignment is not that, actually. Your assignment is this. Mrs. Richens cut it down for us to be the first day back from break. Didn't want to be so brutal. So we went to 264. Problems 7, 9, 13 through 23 odd. And your these are mostly the easier kind. So we don't have many of the rational functions in there. I want to do the first problem with you. I'm going to pause while you grab a book. All right. Number 7. AW. Would you read that to me? Just read me the function. Don't have to read me the directions. All right, good. So we're supposed to make a sign chart for this thing. So draw a number line like this. What do you think the important spots on the number line are going to be? -1 and 3. Oops, -1 and 3. And then at those spots, the answer is 0. Is that going to work in our function? No. So these are empty spots. Again, those spots are not always filled in dots. Sometimes they don't work because 0 is not bigger than 0. All right. Next, I'm going to test in between. What's a nice number between -1 and 3? 0 is probably the nicest number to test. So I'm going to test 0 by sticking it in here, and I would get 1 times -3, be careful, squared. What is -3 squared? Positive 3 times 1 is positive. That is positive. All right. Now I'm going to test 4. And then I stick it into the equation. I get 4 plus 1 is 5. And 4 minus 3 is 1 squared. And those are both positive, so the answer is positive. I don't even care what the answer is. I just know it's positive. Okay. JR, walk me through the last part down here. What do you want to test? Okay. If I stick in -2, what do I get? -1 times -5 squared is 25. Final answer, positive or negative? You are correct. There's the rest of my sign chart. Now the final answer. In the back row by the Christmas tree. I don't want to say names on the video in case somebody's stalking you. negative what? From negative 1 to 3. And are these both parentheses? You are correct. And then 3 to infinity. Parentheses again? Yep. What do I need between them? U for union. Very good. Get that? That's the spots where it was positive. These are the ones that won, so to speak. I wanted ones that were positive. Those were my winners. So the zone between negative 1 and 3, this zone here, and the zone from here to here works. All right. That's how you do it. I think number 9 is going to be a piece of cake for you. I will warn you that when you hit some of the higher level ones, you'll have to factor them. And if they don't factor, factoring is the easiest way, but if they won't factor, then you've got to graph it. And don't forget, if you graph the thing, and it looks like this, where is it positive? Well, it'd be positive in this little zone, and in this zone. And so you'd say from here to here, and from here to infinity. Get what I'm saying? So graphing is an okay way to do it. And it even says in the directions, you know, you can use a grapher. So I do think it's honestly easier, and you need to know how to do these number line charts. So don't get addicted to graphing, because graphing calculators are not allowed in the test. So what if you're supposed to graph the thing, and you only know how to do these by graphing them, and you don't know how to graph it because it's too complicated? Then you're stuck. So these number charts, the sign chart, will always work for you, as long as you can factor it.